Hello everyone. This is a quick introduction to React Graph, a tool I built to visualize the React component hierarchy and the navigation structure in your application. Let me walk you through the core features. First, component hierarchy visualization. React Graph helps you understand how components are structured and how changes in one component can affect others. You can visually analyze the impact of modifications on your overall app. Second, user flow visualization. You can clearly map how a user moves from one screen to another. This includes conditional navigation, for example. On success, navigate to this screen. On failure, navigate to another screen. You can document all of this directly in the tool. Third, component grouping with properties. You can group or classify components using custom properties. For example, if you have a checkout flow with 4 screens, you can assign a property like flow, checkout to each of those screens. Then, using the property filter, React Graph will highlight those specific screens for you. This ensures you never miss any screen when updating a particular flow. Fourth, reverse graph, most important feature. This feature lets you trace where a component is being used throughout the app. It's extremely helpful for refactoring or dependency analysis, and I'll demonstrate this shortly. There is also a built-in info section where you can quickly learn about all features. So, let's get started with the demo. The first thing we need to do is generate the graph. For that, we'll use another library called React Component Scanner. Let's try to run the scanner without any modifications to our project. After running the command, we get a dependency_graph.json file as output. We can simply copy the JSON, go to reactgraph.com, paste it into the input field, and give it a name. Initially, you'll see an error message saying, "No entry route found." Let's quickly go to VS Code and add some entry points. My app uses a bottom tab, so I'll add is entry route to all the tab screens. Now let's run the command again to regenerate the graph. Copy and paste the updated JSON into the tool. And now you can see all our entry screens rendered beautifully. Clicking the plus icon expands the child components. For example, this cell component contains 5 components: screen container, app bar, and cell form. Screen container doesn't show an expand icon because it either doesn't use any components or only uses library components. In this case, it's just rendering a React Native view and props.children. When we hover over any component, it highlights all incoming and outgoing connections, which makes complex nested structures much easier to interpret. Let's explore the cell flow a bit more. When we click a component, the detail panel lists all the components that consume it. We can also click the copy icon to copy its file path and quickly open it in VS Code. We can analyze health, impact, and migration readiness using the Analyze feature. It shows how critical a component is, including how many components are directly or indirectly affected by changes to it. The Health tab scores a component based on complexity, coupling, reusability, and maintainability. Higher score means healthier. Now let's look at the reverse graph. For example, media card is used by 195 components, that's why the graph looks messy. Let me pick a simpler example. Here's a component called listing card. Let's generate its reverse graph. As you can see, listing card is used by two components directly, which are then used by other components, and so on, all the way up to screen components. React Graph automatically traces this chain. Another example is shortlist icon v2, which is used by 25 components. You can clearly see how easy it is to trace a component's reach. Next, we have the Screens tab, similar to the Entry Route tab, but it lists all screens instead of only entry routes. Then we have the Navigation tab. By default, it shows navigation paths from all entry routes. The red number indicates how many screens a user can navigate to from that route. As you can see, the tool has auto-detected all possible navigation paths from the account screen. Let's open our cell flow. From the initial cell screen, the user can go to either Check Valuation, Verify OTP. From the Check Valuation screen, I know there are other screens the user can navigate to that were not auto-detected. So let's add the navigation manually and regenerate the graph. Now we can see the navigation path from check valuation to check price. I'll quickly add the rest of the navigation for the sell journey. And now it looks much cleaner and easier to understand. If we hover over a screen or component, we can highlight both directions of navigation, which is extremely useful when screens transition back and forth. Hovering over a connection line also shows when that navigation happens, if that information is included in the navigate properties. Navigation analysis is not limited to entry routes. We can select any screen from the drop-down and inspect its navigation flow. Finally, let's check out properties. I'll add a new property called isCarCard to some components. After loading the updated graph, we can see this new property in the list. Clicking on it displays a filtered view of all components using that property, and selecting any of them shows its reverse graph. That's all from my side. Thank you for watching.